As many of you begin to succeed or fail in your New Year's resolution, I bet that many of you have not thought about what a year actually is. Some of you are thinking that a year is how long it takes for the Earth to go around the Sun. And of course, you are right. And this is what we all call a solar year, or the time from equinox to equinox. But there are several alternate explanations as to what a year is. One of the first things people say when you ask them about other definitions of a year is a light year. Light years are, of course, not a unit of time, but a unit of distance. A light year is how far light travels in the same amount of time it takes for the Earth to orbit the Sun. That distance comes to approximately 6 trillion miles. One of the first actual alternate definitions of a year is the sidereal year. A sidereal year is the time it takes the Earth to complete one revolution around the Sun with respect to a fixed reference star. We can measure this movement from day to day if we find a reference star such as Regulus, when it's directly south as represented by the green line. If we measure the angle between Regulus and the Sun and then move forward 24 hours, we will see the angle change approximately 1 degree, and Regulus will no longer be south. To find when Regulus will be directly south, we must go back 3 minutes. The difference in position and time is caused by the Earth's revolution around the Sun. As the Earth goes around in its orbit, the angle that we see the stars from changes approximately 1 degree. But the fundamental difference between these two time systems is how we measure time. Solar time measures where the Sun is in relation to us, while sidereal time measures where the stars are in relation to us. This time difference is important especially to astronomers because knowing the sidereal time and a star's location relative to you will mean that the star will be almost at the exact same position on any other night at the same time and location. There is a slight variation in the star's position, even in sidereal time, because of something called precession and nutation. As the Earth rotates on its axis, it wobbles a bit, causing the axis to change its position in space. The complete cycle takes approximately 26,000 years. The effect can be seen as we look back on the position of Polaris, or what we call the North Star. If we go back 5,000 years, we'll see that this is no longer true, and that other stars become the North Star. As the planet precesses, it also wobbles along its cycle, meaning that the shape that the precession takes is not a perfect circle, but a circle that contains zigzags. All of this gives a sidereal day an approximate variation of 0.006 seconds. This leads us to our next alternate year definition, which is called an ecliptic year or a draconic year. Ecliptic year is the amount of time it takes for the Sun to complete its annual apparent motion along the ecliptic with respect to the same lunar node. The time to complete this cycle is different again than that of our standard solar year. The cycle is approximately 346 days. Thanks for tuning in. I'm Sean Rush. Thanks for watching.
Rittenhouse in the 1960s changed their mission statement to be one of education, to bring this science to the public. I'd like to grow that mission. I'd like to keep on doing more education, and I'd like to do some educational outreach like we're going to do this year at the Philadelphia Science Festival.